We humans rely on our eyesight more than any other sense, so when we see one thing but are told another, we can often be quite confused. And I know I was when I was told glass was a liquid. I mean, it looks and feels and behaves very much like a solid, but apparently this isn't the case. So what's the story? Well, we know that glasses are formed when certain liquids cool very rapidly or are quenched. Now, this is done before the molecules can reach thermal equilibrium, and they're physically packed within a cage of surrounding molecules. So they have some kind of short-ranged order, but not very much long-ranged order. And this is indeed analogous to liquids. Solids, by contrast, have short-range and long-ranged order, whereas gases have no order whatsoever. So on the one hand, it's the physical properties that give it solid-like behaviour, but the molecular structure would suggest otherwise. Now, it turns out that glasses aren't the only type of material with these interesting properties. Tomato ketchup is another. Tomato ketchup is an example of a pseudoplastic or a shear thinning liquid, which means when some shear force is applied to it, the viscosity reduces. Now, the opposite of this is a shear thickening or a dilating liquid, and corn flour in water is an example of this. Now, corn flour consists mainly of starch molecules which are quite large, and in water they tend to curl up into what we call colloids. Now, these colloids can be modelled as hard spheres, so when no shear forces or little shear force is applied, the colloids can rub past each other with the water acting like a lubricant. But when we apply a shear force, the colloids physically jam against each other and the liquid quickly becomes a solid. So I can pour some of this solution out just like a liquid, and we can see that it's quite a viscous liquid, but a liquid nonetheless. However, if I then apply a shear force or try and pick it up, you can see that it goes solid in my hands, and I've been able to pick it up. But then if I let go, it quickly turns back into a liquid. Now, I can demonstrate this more clearly with this bowl of marbles and water. Now, the marbles, although they're about 10,000 times bigger than the colloids themselves, they behave in a similar manner. So if I try to insert an object with little shear force or with little force, I can relatively easily get the object to the bottom of the bowl. But then if I try to ram the object, although it penetrates the surface layers, the marbles soon pack up together and start behaving like a solid. So, before we can really explain what phases these liquids are in, we really need to redefine the phases themselves.